Okay, so for the following circuit here, we have to find all of the following here. So we're given the circuit when the switch is flipped when t is equal to 0. So let's draw the circuit when t is less than 0. So when t was less than 0, this was closed. We're going to take the assumption that it's been closed for a very long time. So that means this becomes a closed wire, and this becomes and this capacitor becomes an open wire. The reason is because the formula for voltage at an inductor is equal to the inductance value times the change in current over the change in time, and we're taking time to be infinity. That means the voltage will be 0. So we can pretty much just put a closed wire here. And for this, it's I equals the capacitance times change in voltage over the change in time. We're taking this to be infinity, and yeah, same principle. And this is 2 ohms, and this is 12 volts. And there's a current passing through here called I. So we know V is equal to IR. So V is 12. And we're going to take I to be 4 plus 2, which gives us 2 amps. Okay? And when we flip the switch, so pretty much this is the current passing through the inductor, and obviously the current can't change instantaneously. The second the second t is equal to 0. So that means this current when t is equal to 0 should be 2 amps. Okay, because so right now when t was less than 0, it's 2 amps, and the second we open this, this can't just change in the current here can't just change instantaneously. So obviously we're going to believe it's 2 amps. Now we got to find uh, V for when it was 0. So the voltage here should also so the voltage at this region should be the same as the voltage at this region, and that means, and obviously we see when the current passes through here, the voltage must drop to 0. So the voltage at this resistor should be equal to the voltage here. So V will be equal to 2 times I, and I was 2. So V is equal to 4. And the same principle I said last time, how current here can't change instantaneously, the same goes for the voltage. When we flip the switch, so before we flip the switch, it was 4 volts. But the second we flip the switch, obviously it doesn't change instantaneously. So it's V at 0 will be 4 volts. Okay, so that's out of the way. Now let's look at the circuit when t is equal to 0. Okay. Okay, so we don't have to include this part because this is an open wire, so there's no current passing through it. Okay, so we know the current passing through here is going to be 2 amps, and this voltage is 4 volts. Okay, so that means, and we see these two wires are connected together, so that means the current passing through here is also 2 amps. Now we're told to find the following: di at 0 over dt and dv at 0 over dt. Now notice that this and this, they follow the following formula. Okay, and if we rearrange them, we see these, and we see they match with the ones up here. Okay, so they're trying to find the change in current over the change in time at t when t is 0. and the change in voltage over the change in time and t of 0. So what we have to do is find the voltage at our inductor when t was 0 and the current passing through our capacitor when t is 0. Okay, so the voltage in our inductor, did I say conductor like before? Sorry, I meant inductor. Our voltage at our inductor is going to be the difference of voltage of here to here. Okay, we know the voltage here is going to be the voltage of this, so this is 4 volts, and we can find the voltage. Whoa, wait, what happened? Oops. Let me just erase that. Alright, there you go. Okay, so the voltage here we can actually find. So we know this is 12 volts here, and there's a voltage drop at this region. So it'll be 12 minus 4 times 2, which gives you 4. So the voltage here will be 4. Now, the voltage in this uh, inductor will be the difference of the voltage here and here. So it's 4 minus 4, which is 0. So that means this will be 0. And that means di of 0 plus over dt is 0. It'll be 0 amps per second, okay? So that's what we're going to put here. There we go. Now, that part's done. So for this one, we have to find the current passing through the capacitor when t is 0. And we see the current passing through the capacitor is 2 amps. So it'll be 2 over 0.1 fards. And let me see what that gives me. That gives me 20 volts per second. Okay? So that's your answer for this one. Now the last part of the question, it wants us to find I when t goes to infinity and v when t goes to infinity. So the circuit for when t is greater than 0, it'll look something like this. Okay, same principle as last time. The inductor that was originally here, its voltage is equal to the inductance value times the change in current over the change in time. Time is going to infinity, and the current here is going to be capacitance times the change in voltage over the change in time, and time goes to infinity. So since this is an open wire, there's actually no current passing through it. So the current here is 0. So I of infinity will be 0. Okay? And since I is 0, that means this resistor is kind of useless. So we can just ignore that. And that means V, the voltage here, should be the same as the voltage here. So that means V of infinity is 12. Okay?